For this lesson, we will be doing the notes for 6.1 Day 1, Slope Fields and Euler's Method. So the first thing we're going to talk about are some definitions. A solution is when you are able to solve for an original problem. So that's going to be your y equals whatever your function is. Typically we get this by taking an integral if you have a derivative. Now a general solution would mean that we don't know much information and we don't know a point that it goes through. So you might, for example, get 2x plus c as a solution. And if we don't know a point that the line crosses through, we won't be able to figure out c, so we just leave it as a general solution. A singular solution is when we're able to solve for c. So maybe we've solved for c and we've gotten 2x plus 4 because we know c is 4. Now an order would be maybe you're working with a differential equation and you have to figure out either the second derivative or the first derivative. The order of a differential equation is the highest derivative in the problem. So for example, on number 1, we have a differential equation, y double prime minus y. That is a second order differential equation because it uses the second derivative. So we're actually going to be determining whether these three functions are solutions of this differential equation. So in order to figure that out, we need to first find the second derivative. So for a, if y is sine, y prime would be cosine. Y double prime would be negative sine of x. So if I follow the directions here, y double prime minus y, that does not equal 0. That actually is negative 2 sine of x. So sine of x is not a solution. Letter B, I'm going to find the first derivative. This is actually a chain rule, so I have to take the derivative of the inside, which is negative 1. So negative 4 e to the negative x. Y double prime, the inside derivative is negative 1, so that gives us positive 4 e to the negative x. So now if I follow the directions for the differential equation, I need the second derivative minus the original problem. That does in fact equal 0, so B is a solution. For part C, the first derivative of c e to the x is also c e to the x, and same for the second derivative. So y double prime c e to the x minus y c to the x is also 0, so C is also a solution. So thinking about graphs, let's say we're going to go back to that 2x plus c example that I gave at the beginning. So let's say you've got a general solution of 2x plus c. I can't graph that unless I know what c is. I know it's going to be some straight line, right, with a slope of 2, but c could put it anywhere. If c is 0, it would look like this. If c is 5, it would look like that. If c was negative 2, it might look like that. So the particular solution is when we actually know what c is. And we get that by being given an initial condition. And that is a point that we're given in the problem that we can plug into our equation so that we can solve for c. Okay, so we're going to flip to the back. We're going to be checking some differential equations and solving for c. So if we look at example 2, we have a differential equation, x y prime minus 3y equals 0. We're going to verify that y equals c x to the third is a solution. So first thing I need to do is find the first derivative because that's what we need here. Y prime, this is going to be a typical derivative. We're going to multiply and subtract our exponent by 1. So now I'm going to plug in x times y prime minus 3y, which y is cx to the third, equals 0. So this simplifies to 3cx to the third which is a true statement. So that checks out. That's a solution. So now we're going to solve for c. I know y equals c x to the third, but that's just a general solution. So I'm given some points. Y equals 2 when x equals negative 3. So I'm going to plug in 2 for y, negative 3 for x. Negative 3 cubed is negative 27. So c would be negative 2 over 27. So the very last step is to rewrite our problem so that we can plug c in. So y would now equal negative 2 over 27, x to the third. Okay, so we're going to try the same thing with example 3. This time we have a differential, or a solution, a general solution, y equals ce to the negative 2x. So the differential equation requires us to have the first derivative. So the first derivative, it's a chain rule, so the derivative of the inside, negative 2, times the derivative of the outside, and the derivative of e to the x is still e to the x. So now I'm going to verify. I'm going to plug in y prime, negative 2 ce to the negative 2x, plus 2 times y, which is ce to the negative 2x, equals 0. So this simplifies to 2 ce to the negative 2x, which they cancel out. These are opposites, so we get 0 equals 0. So it checks. So now we're going to solve for c. Our general solution, again, is ce to the negative 2x. And we're given y equals 3 when x equals 0. So I'm going to plug in 3 for y and 0 for x. Anything to the 0 power is 1, so c would equal 3. So my particular solution, now that I know c, is y equals 3e to the negative 2x. Okay. The last two problems, we're actually going to start solving differential equations. Now there's a process of steps that we want to go through. These often show up on the AP exam and the FRQs, and they're worth quite a bit of points because there's a lot of steps to them. So let's start with number 4. First thing we're going to do is do what's called separate the variables. Basically, we're going to cross multiply and move this dx over to the other side. So dy equals 3x squared dx. And now I'm going to solve for y. So if I have a derivative and I want to get rid of that, I'm going to take the integral. The integral of the derivative is just y. And over here, I'm going to follow my rules for integration. I'm going to add and divide. So that would be x to the third plus c. And because I don't have any other information, I can't solve for c. So there's my general solution. We're going to do the same thing with number 5. So first, I'm going to cross multiply that dx over to the other side. And I'm going to undo the derivative by taking the integral. So I get y equals, now this is not a straightforward integral. I can't split this up. So the only other thing I'm going to try to do is use substitution. So if I look at this, I'm going to set u equal to the denominator. du would be 2x dx. So that means I have to add in a 2 and take out a 1/2. So I'm going to rewrite this. This would be 1/2 the integral 1 over u du. So hopefully we remember our rules for integrals, that the integral of 1 over u is the ln of u. plus c. And I brought down my 1/2. And then the very last step, of course, is to plug back in for u, which is 1 plus x squared plus c. So there's our general solution. So the only other thing that you might notice is if this were on a multiple choice test, they might drop the absolute value and use parentheses instead. And why we can do that is because we know 1 plus x squared, there's no way that's going to be negative. It's always going to be a positive value. So you might see them drop the absolute value and just use parentheses there. Okay, this concludes the lesson. Feel free to go back and redo any questions that you need to focus on, or you can ask me for help in class.